Hello, everyone, and welcome to our fifth episode on the Neural Network. My name is Vasudevan Lakshman, and I'm here with my co-host,
Armaan Priyadarshan. Today we'll be joined by Nihitha Reddy, a senior at Mass Academy, to discuss her experience with ML, which she made use of in her MCEF project last year. Her project used biomarker analysis to enhance psychiatric disorder classification from MRI scans. Nihitha, would you like to introduce yourself to our listeners?
Hi, my name is Nihitha Reddy, and I'm a senior at Mass Academy, and I'm majoring in computer science and have an interest in machine learning and data analysis.
all pretty cool stuff we got there. Can you please give us a quick elevator pitch for your project?
Yeah, so my STEM project basically took psychiatric disorders and looked at the MRI scans to find biomarkers. So basically the problem right now is that when scientists or doctors look at MRI scans for different disorders, they get confused between them because they all have similar phenotypes. So for example, major depressive disorder and bipolar disorder, they're extremely similar. So 60% of those with major depressive disorder have been misdiagnosed with bipolar disorder. So after finding biomarkers, I then highlighted each of them using bounding boxes on the MRI scans and then used Inception v3 as a multi-class classification algorithm and analyzed all of the scans in order to get a higher accuracy for the classifications.
So what kind of biomarkers did you use?
So the main ones that I looked into had to do with within each disorder, there are about 5 or 6 biomarkers that were highlighted. So for example, if you look at schizophrenia, you'd look at neurologen, which is NRG1, which would be the chemical formula for it. Or if you were looking at bipolar disorder, you look at gray matter density, or major depressive disorder, functional connectivity, or cortical thickness. So with each of them, I just used a software that the professor that I was working with helped me find, which was called SCAR. And then basically it'll go through whatever ones you find, and it'll help you highlight each one individually.
And were the biomarkers visible in the MRI scans? Were they kind of visual indications?
Yeah, so basically phenotypes are visual comparisons of genes. So if you think about an MRI scan, you know how you see squiggly lines or straight lines or whatever the case is. Certain things would be highlighted depending on the source. If you're looking at schizophrenia, mean and radial diffusivity are the most common. So you'd start to see say you're looking at a scan from 3 months ago and there was a straight line. 3 months later, it would start to turn into a more curvy line and it would look like a C.
And one other question. Why did you decide to use Inception v3 in comparison to other classification models?
So originally I used Inception v3 because it's a lot more common for a deep learning model, but also my reasoning for choosing Inception v3 was because of its transfer learning part. So transfer learning is basically when you take a model and then you adjust it to fit your own criteria. So for me, I started off with really simple models that were just binary classification, and then after that I noticed that they weren't working as well because there were so many details, I guess, that you had to analyze. So then I started moving into Inception v3 because of the fact that out of all the transfer learning models, Inception if you were to look at a graph of the 5 most popular transfer learning models, Inception v3 is most common for image classification compared to other ones like VGG16. So that was my main thought process for that. But then Inception v3 kind of has a lot of layers, and for a data set that's pretty small because there's not many MRI scans out there for psychiatric disorders, you need something that's less complicated. So I started to remove layers from Inception v3, which is became my modified Inception v3 model.
Yeah, I mean, it seems like a pretty cool topic, and it's very niche to a particular field. So what inspired you to choose this topic in particular?
So my best friend's sister was actually diagnosed with bipolar disorder in 2019. And then after about a year of going through treatment for it, they actually found out that she had schizophrenia. So this not only took her back in terms of like her mental progression, and also in a way made it even worse, because not only are you still dealing with the disorder that you had in the first place, but now you know that the past year of treatment has been a waste, so it kind of takes you back even more. But also it caused her family financial problems, and she started to become addicted to the substance that, like, or the prescribed drug that she was using to help her face her bipolar disorder. So when I first found out about that, because my friend's family was so close to me, I saw the effect it was having on them. So I didn't really have the resources in middle school to be able to solve something like that. But as soon as I came to Mass Academy and we were, like, kind of learning about the STEM project, that was the first thing that popped into my mind because of the, like, firsthand impact I was seeing. Because even though it's been, like, almost 4 years, to this day, I still see the impact on their family.
That isn't a really awesome reason. I think that's what you did for what you did for your project could potentially be very beneficial to other people who suffer from the same process that your friend suffered from, your friend's sister. And I guess, do you have any brainstorming advice for coming up with ideas like these? Like, your idea was, in my opinion, like, really good.
I think in terms of coming up with ideas, the most important thing is being able to find a project that you're passionate about. So there are so many issues around the world that are prevalent and important to figure out, like, a solution for, but if it doesn't mean something to you, it's really hard to find the motivation to continue with your project. But also, I would say, like, that being said, every project has some sort of solution to it. Like, I guarantee there's no one right now that is studying something that hasn't been done at all before. But I feel like one of the most important things is your approach to that project. So, like, for me, like, classifying, like, disorders, like, whether, like, neurological, like, any type of disorder has probably been done before. But not everyone does it with an Inception V3 model. Not everyone looks at biomarker analysis. So, like, it's really important to modify your approach, and you can still always try new things for any project that's been done before.
Yeah, I totally agree that building off of previous research and kind of augmenting it is a really creative way of approaching brainstorming.
Yeah, absolutely. Especially given the vast amount of fields that could be researched, like having unique factors that add on to that could definitely create a unique project, and alongside that, a very impactful project like yours itself. What were some of the technologies that you used? I know you mentioned Inception V3, but other ones that you used also inside your project.
Yeah, it's like Python or like whatever programming language or libraries.
Yeah, so in terms of getting my actual data set, I got it from, like, okay, so like I said before, MRI scans aren't very common to, like, be able to find. So in order to get mine, I had to go through, like, 4 different hospital databases, and then I finally found one from USC that was able to give it. But, like, then after that, it's like the whole pre-processing thing to make sure that all of your MRI scans are, like the same in terms of, like, color, orientation, shape, like, all of that stuff. And then after that, I used DeepNote to actually code my project. So when I was working with the professor, I used Google Colab just so that they could easily see it, but then I switched to DeepNote for, like, the actual coding part of it. And then for my machine learning models, I started off by using an SVM. So SVMs are more simple models, so it's kind of like that was, like, my base case of a model. And then after that, I worked into, like, random forest or canine, but, like, it's kind of like mixing models together until you find, like, I guess, like, the right combination, if that makes sense, because you don't have to, like, only use one model to create your algorithm. But then I ended with Inception V3, which was the transfer learning model.
Yeah, you mentioned that you got data from USC. Did you happen to get that data publicly or privately, or how'd you access it?
That data was from so it's technically a public database, but in order to actually collect the data, you have to, like, fill out an application. So there's this club at USC that's for, like, neurological MRI scans. So they put it out, and, like, basically once you fill out this application, they'll give you a key, and then that's how you get access to the data. And then after a year of using that data, you have to provide them with some sort of evidence that, like, you used their data for the greater good.
Oh, pretty cool.
I had one other question. So, in the end, like, how did your model perform? Was it like effective? Was it accurate?
So with the Inception V3, like multi-class wise, I wouldn't say it's the most accurate, but binary class. So I did one where it was comparing bipolar disorder and schizophrenia, and then I did one where it was major depressive disorder and ADHD, because those are the most common to get mixed up. And those performed pretty well. It was like low 90s for the accuracies for both. But I think a big part of making the multi-class classification algorithm better, which would be part of my future works, is adding to the biomarker analysis across all four of them. So like from the biomarker analysis I did, I was mainly picking things like, for example, like I said, bipolar disorder and schizophrenia. I was picking things that bipolar disorder had that schizophrenia didn't have, and vice versa. So by doing that same process across all four of them, it would be able to increase the accuracy of the multi-class algorithm.
What skills did you say you acquired from this project?
I would say the main skill I acquired, like like not even scientifically, but in general, like perseverance.
Mm-hmm.
Like there was a lot of times where I thought like I wouldn't get my data, or my ML model wasn't gonna work, or like the biomarkers were too complicated. But kind of just like sticking with it and trying your best was like a really important quality, I would say, to develop over the term of your project. And also I would say another one is, in general, like learning how to read research papers, how to write about research, how to present research. Like those are all really important things that will be useful later on too.
Mm-hmm. Yeah, that makes a lot of sense. Perseverance is definitely one of the aspects of STEM that's kind of been the common theme along a lot of these projects.
Especially computer science.
Yeah, no, like before, like the STEM fair, everyone was just like not sure if they're gonna make it or not, and now that we're done with it, it's just such a nice feeling.
Yeah.
I mean, if you could do the project over again, what do you think you'd do differently?
I think my main thing I would do differently is, I would say, like, first, time-wise, I would plan it out better, because I feel like I kept waiting on the data sets, and, like, honestly, like, that's one of the most important parts of the project, obviously. And then I think the second thing I would say is, with my machine learning models, I wish I used more types of machine learning models, or, like, kind of branched out in terms of which ones I was using.
Do you have any like ideas for other models you could use?
I would want to look into more. So, like, I think one of the big things, like I mentioned before with Inception V3, I removed some of the layers because it was too deep. So I wish I went through that same process with other transfer learning models, like VGG16.
Mm-hmm. And how exactly did you manage your time effectively? Because that's like one of the biggest things I think with STEM. Like one of the things that like gets on people's projects the hardest is just. Oh, sorry,
Yeah.
Go ahead.
I was gonna say, I think a big part of it is holding yourself accountable. So like I said before, like it's really important that you actually care about your project and like have a personal connection to it. So I feel like as long as you keep reminding yourself why you're doing your project, it helps you stay accountable, and then keeping that accountability helps you progress through your project at a good pace. But I think like in general too, one of my biggest problems, I would say, in terms of like timing or like planning things out, is like when I get stumped, like I just stop there. But I think it's really important to help, like, or to remember that like there's always someone that can help you. So like if you are in a situation like that, like don't be afraid to ask someone for help so you can keep moving along instead of just sitting on one problem for a long time.
Yeah, absolutely. I know for my project, I had to reach out to a lot of professionals and get their input, and that was able to help me create a successful product towards the end. But with any STEM project, regardless of like the work that you put in, at the end of the day, it comes down to the communication of the project itself. So do you have any advice on project presentation and how to effectively communicate your results, your data, and your whole entire process as a whole?
I think staying confident is the most important thing by far. And like also I would say standing your ground. So like during my February fair, I had a judge that like wasn't very open to new ideas in terms of ML, so they didn't think that the way I was approaching the problem made sense or worked or whatever the case was. But I was able to prove them wrong by showing them my code and walking them through every step of the way that I took, or the process that I took. So it's really important to make sure that, like, whatever you're doing, like, you know what you did because you're the one that did it, obviously. So make sure that you're able to back yourself up and stand your ground even when people grill you or ask you really difficult questions, and stay confident because obviously you put in the work for your project, so use that as your motivation to keep going through it.
Yeah, that's great advice. And would you say that you have any future steps or continuations of your project you might want to explore in the future?
Yeah, so my first one was, my project right now, like, was mainly intended for, like, doctors or scientists to be able to use when they're analyzing MRI scans as, like, a backup method. But I think something that would be really helpful is if the patients themselves were able to have, like, some sort of, like, backup diagnostic. So, like, even though, like, my app would, like, if I built an app for this, it wouldn't be able to, like, actually diagnose someone. It would be able to give them some sort of reassurance that whatever their doctor said was accurate. So, like, being able to have an app where someone can, like, import their MRI scan and then it'll give them the accuracy based on, like, an on-time ML model.
And would you have to adapt your model for mobile if you were to do that, or would you use, like, some sort of backend or model, or would you run on the device, or what?
I would run it on the device, I would say. It would take a little longer, probably. If, like, it would take, like, a couple minutes for, like, the ML model to, like, keep running over and over again. But I think that's more worth it than, like, having to go through the process of, like, converting it to, like, an iOS applicable model or whatever the case is.
Mm-hmm.
Yeah, that makes sense. Alongside completing your STEM project, were there any other ML projects that you're currently working on, or worked on in the past?
Yeah, so over the summer of 2022, I did Beaver Works. So as part of Beaver Works, I took the Medlytics course, which was, like, using machine learning for, like, medical analysis. So through that, like, I learned different things, like looking at, like, frequencies, like, if you're looking at, like, hearing or, like, image classification, like, whatever the case is, like, there's a lot you can, like, I used that course to, like, kind of build my foundation. And then after that, I continued to explore image classification more. So I used, like, an ocular disease set with 9 different diseases that I found on Kaggle, and then I used image classification to be able to, like, classify each of those diseases.
What kind of classification models did you use for that?
That was where I actually used SVMs for the first time. So using an SVM for that kind of led into my STEM project in the first place.
Yeah, that's pretty cool. I know SVMs are difficult to work with. So what was your experience throughout the whole entire process? Like, did you find that the learning curve was difficult?
I feel like for me, it wasn't too bad because I learned it from Medlytics. So, like, I kind of had, like, a base to be able to, like, know how everything works. But I think for someone that hasn't had, like, experience in terms of, like, having an actual teacher, it might be a little harder to get the grasp of things. But for me, because, like, I was, like, seeing this, like, all day, every day for, like, 4 weeks, I think it was a lot easier.
And would you say the project helped prepare you for your eventual image classification on your STEM project?
Oh, for sure, yeah. I think it was more difficult in the way that, like, I needed, like, the bio aspect of my project, but in terms of machine learning, I already had the experience with different models, and even though, like, I'd never worked with, like, transfer learning or, like, even, like, multi-class and, like, generally, like, with going, like, deep learning models are a lot more complicated than I would say, like, an SVM is. But just having that backup of, like, how to code or how to implement something or how to run a model was really helpful.
Yeah, and I haven't asked you this still, but what framework do you use to implement your model?
I use TensorFlow.
All right, cool.
For our listeners who don't know, would you like to elaborate on what TensorFlow is and its amazing capabilities?
Okay, so TensorFlow is an amazing framework where you can implement different AI models and different architectures. So it does a lot of, like, the behind the scenes work for ML that you wouldn't normally do. So, like, the actual math aspects of it. So like it's used for things like natural language processing or like image recognition, handwriting recognition, whatever the case is.
Thank you so much for the interview, Nihitha. Is there anything else you'd like to leave our audience with?
Have you guys had an experience with ML models?
Yeah, that's a fantastic question.
Wait, no, nope. Okay. No, I'm all set. Thank you for having me.
Okay. Sounds good.
Thank you to all our listeners. Yeah. Thank you to all our listeners, and make sure to watch out for our next episode. Armaan, Vasu, and Nihitha out.